The study of dynamics is going to let us observe, measure, and understand the dynamic world around us, so it's of great importance in physics. We're going to be looking at motion, forces, momentum, and energy, and that's going to give us some of the building blocks to delve into some even deeper understandings. We're going to start off with motion, and let's consider this slightly odd question. A woman owns 3 cats. In which direction does she own them? How would you answer a question like that? Well, like I said, it's a silly question. Owning cats has a magnitude, 3 in this case, since there are 3 cats, but it doesn't have a direction. Or how about this question? A boy runs to school in 5 minutes. In which direction does he run? Now this one has a direction, towards school. So you're probably way ahead of me here. We're looking at the difference between scalar and vector quantities. A scalar quantity is one that has magnitude only, owning 3 cats, having a mass of 50 kilograms, a speed of 2 meters per second. A vector quantity has magnitude and direction, running towards school, having a weight of 500 newtons pulling you down, a velocity of 2 meters per second to the right. Now in this unit, we're focusing on the difference between speed and velocity. So, speed has magnitude only, velocity adds a direction. The clearest demonstration of the difference is travelling in a circle, I think. So imagine we tie a tennis ball to a string and spin it around your head, and the ball will travel at a nice, steady speed. Let's say it travels in a circle with 4 meter circumference in a time of 1 second. That's a speed of 4 meters per second. It's not speeding up or slowing down at all. It's just moving with a nice, constant speed of 4 meters per second. But, on average, its velocity is 0. Look at where the ball starts and stops for 1 spin. It's in the same place. If we think about direction, it hasn't really gone anywhere, so we could say it hasn't really moved. So the velocity is 0 because velocity has a direction as well. Now if we actually refer to this as 0 displacement, with displacement measuring the distance from the start point to the end point. 0 here. Another way of looking at it is that during this circle, sometimes the velocity is upwards, sometimes downwards, sometimes to the left and sometimes to the right. Since the arrows cancel each other out, overall the velocity is 0. So, now you know about scalars and vectors, you'll need to do some experimental work. You'll be looking into speed, velocity and acceleration, so let's look at some of the relationships you'll come across. Firstly, let's be clear with things. Speed equals distance over time is not really what we want now. It's a bit vague. Average speed is equal to the total distance travelled divided by the total time taken. If we look at a distance time graph, let's start with a straight line. Right. We've got distance on the y-axis and time on the x-axis. If I calculate the gradient using rise over run, that's y2 minus y1 over x2 minus x1, or distance travelled over time taken. So the gradient is equal to the speed. Let's complicate things a little. This graph shows a more realistic trip with changing speeds. I can see that they are moving quickly here because the steep gradient means the distance changes a lot in a certain amount of time. And this is less steep, so slower. And here, the horizontal line means distance is not changing. Speed is 0. They have stopped. So how about overall? How do we take all of these different slopes and work out an average speed? What do you think? What would you do? Well, we could spend ages working it out, but actually average speed is total distance travelled over total time taken. So we only need the end values and we get the right answer. Simple. This is a popular question, so don't get caught out wasting time trying to do it the long, complicated way. So that's an introduction to motion covering scalars, vectors, speed and velocity. Do try to make sure you get some experimental work done on this, because that's really going to help to deepen your understanding before you go on to look at acceleration.